let us proceed with the last method of obtaining IBFS, what is called as Vogel's approximation method, which is also called as VAM. Now, Vogel's approximation method is actually a heuristic method and it is preferred to the method which are described above. That means Vogel's approximation method is actually preferred in obtaining IBFS as compared to the other four methods. In the transportation matrix, if an allocation is made in the second lowest cost cell instead of the lowest, then this allocation will have associated with it a penalty corresponding to the difference of those two costs due to loss of advantage. That is, what I'm trying to say is, if we compute the difference between the two lowest cost for each row and column, we find the opportunity cost relevant to each row and column. It would be most economical to make allocation against row or column with highest opportunity cost. For a given row or column, the allocation should obviously be made in the least cost cell of that particular row or that particular column. Vogel's approximation method therefore makes effective use of the cost information and yields a better initial basic feasible solution than obtained by any other earlier discussed four methods. Let us look at the steps involved, right? Just go through these steps, and as usual, I'll explain you this with the help of example. The only thing is, Vogel's approximation method makes use of a terminology called as penalty, and hence it is also called as penalty method. So these are the three steps involved in Vogel's approximation method. Let us see how to go about in finding IBFS using Vogel's approximation method. Okay, now watch out. I'm going to take the same example, right? I have the supply and demand, and it is a balanced transportation problem. And whatever you see on the left hand side matrix 19, 30, 50, they're all cost involved. Okay, and you will see a little bit of difference in this method as compared to other four methods. On the right hand side of the screen, you have a couple of boxes on the top of which I have written penalties, and also on the bottom left side of the screen you have same couple of boxes where I have written penalties. So I'm going to write an integer number in these boxes one by one. They are called as penalties, and that is the prime reason Vogel's approximation method is also called as penalty method. Now let us understand how this penalty method, how these penalties are calculated. Initially, you have to calculate penalties for all the rows and all the columns. So we have 3 rows, we have 4 columns, so I'm going to calculate 7 penalties. Now how the penalty is calculated? The penalty is calculated like this. Pick up the lowest cost and the second lowest cost in each row and find out the difference, right? So what I'm trying to tell you is, look at the first row, right? The difference between the least cost and the second least cost will be considered as a penalty for that particular row, right? So the first row least is 10, the second least is 19, and hence the difference is 9. So 9 is the penalty for the first row, which I will write on the right hand side. So this is my 9. Similarly, when I go to the second row, the least is 30, the second least is 40, so the difference is 10. I write it against the second row. Third row, the least is 8, second least is 20, so the difference is 12. I am going to write it here. Okay, so I have 3 penalties as far as row are concerned. Now let me shift to the column. When I look at the first column, the least is 19, the second least is 40, so the difference is 21. So I write 21 here. Watch out carefully, 21. Then I go to the second column, least is 8, second least is 30, does not matter which one it is. The difference is 22, I write this 22. Okay, don't bother about this circle as of now, I write this 22. In the third column, it is the difference between 40 and 50, that is 10. And in the last column, it's the difference between 10 and 20, it is 10. Now I have totally 7 penalties, 3 for rows, which is 9, 10, and 12, and 4 for columns, which is 21, 22, 10, and 10. Now the next step is, out of all these penalties which is there for you, you have to pick up the highest penalty. Got it? The highest penalty among all these 7 is 22. Right? You don't need to worry rows and columns separately. You have to keep the entire set of penalties that you have calculated in this step, and then you have to pick up the highest. So among 9, 10, 12, 10, 10, 22, and 21, the highest is 22. I will circle that 22. Now, this particular 22 is the penalty which is associated with the second column. Am I right? It is associated with the second column. Now what you have to do is, you have to make the allocation in the second column. Now how the allocation is done? In this particular second column, you have to pick up the least cost. Right? What is the least cost? 8. Understand, this is your second column. The cost associated is 8, 30, 30. The least cost is 8. In this particular least cost, you are supposed to allocate as much as possible. Obviously, you have to keep your supply and demand in mind. So I will allocate 8 here. Correct? Now once I allocate 8 here, it will take care of my column requirement. Okay, so this is what is called as end of the first step in Vogel's approximation method. Now, once you do the allocation, you have to proceed in the similar fashion. Means you have to again calculate the set of penalties. Okay, you have to again calculate the set of penalties. Now, in the second step, when I calculate the set of penalties, just have a look at it. There's no change in the penalty in the first row, but in the second row, I'm not going to consider this 30 anymore because this cell is already filled. So I have 70, I have 40, I have 60, out of which 40 is the least, 60 is the next least, and the difference is 20. Similarly, in the third row, I have 20 and I have 40, so the difference is 20. Similarly, I calculate the penalties for the column, but here, since the second column allocation is already done, I am not going to calculate the penalty for the second column. And hence, here, I'll end up just writing a hyphen. Now, hyphen indicates the penalty is not calculated for that particular column. Now I have totally 6 penalties, 9, 20, 20 for the row, and 21, 10, and 10 for the column. Out of these 6 penalties, I pick up the highest, which is 21, which belongs to the first column. Now in this first column, the least cost is 19, and hence I am going to allocate as much as possible for this cell whose cost is 19. And what I can allocate there is only 5. That will take care of my column requirement because the demand here is only 5. Now again I'll end up calculating the penalties. Now this time in the first row it will be the difference between 50 and 10. In the second row it will be the difference between 40 and 60, and in the third row it will be the difference between 20 and 70. So this is the penalty in the third step, 40, 20, 50. And the column penalty, I'm going to only worry about third and the fourth column because first and second is already over. And the penalties for the third and the fourth column is 10 and 10. 40 and 50, this is 10. This 10 and this 20, it is 10. So among 40, 20, 50, 10 and 10, the highest penalty is 50, which belongs to the third row. And in this third row, the least cost that is available among 70 and 20 is only 20, and I'll allocate as much as possible, and I'll end up allocating 10. That will take care of my row requirement, that is third row requirement. Now I go about in calculating the penalty once again. So it is difference of 10 and 50 and 40 and 60. So I get this. Of course, I'm not going to calculate penalty for the third row because the third row is fully occupied now. I'll end up calculating the penalty for the third and the fourth column. Right? Now I have 4 penalties, 40, 20, 50 and 10, out of which 50 is the highest penalty, which belongs to the fourth row. And in fourth row, I'll pick up the least cost, that is 10, and I'll allocate as much as possible for this particular cell, which comes out to be 2. Okay, so I'll allocate 2 and that will take care of my row requirement, correct? So I'll allocate 2, that will take care of my row requirement. Then this cell will be left out. I just blindly put 2 here. And then these 2 cells I'm going to fill up blindly because I don't need to calculate the penalties. And this is how I land up allocating I land up doing the allocation for all the cells of this original matrix. So whatever I have written in green color inside the matrix, they are all the allocations done to that particular cell. And let me see what is the cost involved in shipping the products using Vogel's approximation method. So if you look at this, it is 5 into 19 plus 10 into 2, right? So you proceed like that, and the total cost involved in shipping the products for this transportation problem through Vogel's approximation method works out to be 779. Okay. Now let me do a simple comparison of this IBFS method. We have seen the 5 methods, right? So first one was northwest, and then you had row minima, then you have column minima, then you have least cost entry method, and you have Vogel's approximation method, right? Now with respect to first example, we have solved the first example using all the 5 methods, correct? And the cost involved using all the 5 methods were like this. The northwest gave us the IBFS as 1015. The row minima method gave us the cost as 1110. The column minima gave us 779. The least cost entry method gave us 814, and Vogel's approximation method also gave us 779. Now look at this, the variation in the IBFS, right? So even though the problem statement was same, correct, you have different IBFS which is coming out from different methodologies, right? So it is not necessary that the all the 5 methods should give you IBFS as same, right? So it is left up to the professional to use any of these methods to obtain the initial basic feasible solution. But literature has shown that if you use Vogel's approximation method, right, the number of iterations that you take in the next stage to obtain the optimal solution for the transportation problem will be a little bit less as compared to any other method, right? So unless and otherwise it is stated in the problem statement, right? Say for example, the problem statement may come to you like this: find the solution for the following transportation problem by first obtaining the IBFS using Northwest method. Now, if you have a problem statement like that, it becomes mandatory for you to obtain the IBFS using Northwest method. On the other hand, if the problem statement is simply like this: obtain the optimal solution for the following transportation problem. If that is the problem statement, then it is liberty given to you to use any method to obtain IBFS. But my suggestion would be, when nothing is made mandatory, then please implement Vogel's approximation method to obtain the IBFS, because Vogel's approximation method, right, will always give you a better IBFS as compared to any other method. That's the first advantage. And the second advantage is, in the next stage where we proceed for optimality, the total number of steps required or the total number of iterations required to obtain the optimal solution will be less compared to any other methods, right? So this is all about the transportation problem in terms of obtaining the initial basic feasible solution. Try to solve one more transportation problem. We find initial basic feasible solution using Vogel's approximation method. Now you have a transportation problem here. It is a 3 rows and 4 column matrix, and the supply is 250, 300 and 400, and these are the demands. Now let us check whether the total supply is equal to the demand. So this is 250 plus 300, that is 550 plus 4. So the total supply is 950, and then the addition of these 4 also comes out to be 950. Right? So the supply is equal to the demand, and hence we can go ahead in implementing Vogel's approximation method to find the IBFS for this problem statement. Now, as you know earlier, with the help of earlier example, that Vogel's approximation method basically works with respect to the penalties, right? So I have drawn the matrix once again here, and the cost involved, which is there in the problem statement, I am going to write it at the top left corner of the matrix. So I have the cost written like this. Okay, so I have done with the cost, and now what I am going to do is I am going to find out the penalties. Initially, the penalties will be calculated for all the rows and all the columns. So I have 3 rows and 4 columns, so I am going to calculate a total of 3 penalties for rows and 4 penalties for columns. So let me go ahead in finding out the penalties for these rows and columns. I just write the word penalty here, right? So the least element in this first row is 11, the second least is 13, so the difference is 2. Similarly, 10 and 14, the difference is 4. 10 and 13, the difference is 3. So these are my 3 penalties as far as rows are concerned. Now let me find out the penalties for the columns. The least element is 11, second least is 16, so the penalty is 5. Similarly, I have 13 and 18, so the penalty is again 5. So here 13 and 14, the penalty is 1, and 10 and 10, the penalty is 0. Right? So I have all the 7 penalties. Now I have to pick up the highest penalty. Correct? Now the highest penalty in this case is 5, which is occurring at both the places. Now I have to do some sort of trial and error basis. Now if I consider this as the highest penalty, the lowest cost in this particular cell is 11, and in this particular cell 11, I can allocate as much as possible, that is 200. So if I consider this as a penalty, then I can allocate 200 in this particular cell. Now if I allocate 200 in this cell, then the total cost will be 200 multiplied by 11, that is 2200. That is the cost I am going to get. On the other hand, if I consider this particular 5 as a penalty, the least cost is 13, and in this particular least cost cell, the maximum that I can allocate is 225. Now 225 multiplied by 13 is going to be definitely more than 2200, and hence what I am going to do is I am going to consider this particular 5 as the penalty, and I am going to allocate as much as possible. So I am going to allocate 200 in this particular cell. Now once I allocate 200 in this cell, that will take care of my column. Right? Now I proceed in calculating the penalties once again. So 13 and 14, the penalty is 1. 10 and 14, the penalty is 4. 10 and 13, the penalty is 3. I am not going to calculate the penalty for the first column because the first column allocation is already done, and the penalties for the remaining 3 columns will be as usual 5, 1 and 0. Now out of these 6 penalties, the highest penalty is 5. Now this is the highest penalty. In this, the least cost is 13, and let me see how much I can allocate. So I have 200 already allocated, so I am left out with only 50. So I am going to allocate 50 here. That will take care of my row allocation totally. Now let me calculate the penalties. Once again, since this particular row is already occupied, no penalty will be calculated here. Now this will give me again 4 and 3 respectively. This I won't get it. 18 and 24, the difference is 6. 13 and 4, the difference is 1. 10 and 10, the difference is 0. Now among all the penalties at this particular step, the highest penalty is 6. So I will circle this penalty. and I'm going to pick up the least cost, which is 18. Now let me see how much I can allocate maximum in this least cost 18. So already 50 is gone, so I am left out with 175. So I can allocate 175 here. That will take care of my column requirement. Now let me once again calculate the penalties. I get hyphen here, I get 4, I get 3. These two columns I don't need penalties because now this particular column penalty is also, allocation is already over. Now this will give me 1, this will give me 0. Now the highest penalty is 4, which is on the row side. Now this particular row, the least cost is 10. Let me see how much I can allocate. I can allocate 125 here because 175 already allocated. 175 plus 125 is 300. So that will take care of my row requirement. So I am left out with only these two cells. You don't need to calculate the penalties. You can blindly do the allocation keeping the supply and demand in mind. So nothing is allocated in this column. So I'll directly allocate 275 and then I can allocate 125 here. So 275 plus 125 is 400. You can also have a look at this. 125 plus 125 is 250, right? So this is how I do the allocation using Vogel's approximation method. Now let me find out the total cost that is involved, right? Now the cost is 200 multiplied by 11. So 200 multiplied by 11 plus 50 multiplied by 13 plus this one 175 multiplied by 18 plus this one 125 multiplied by 10 plus 275 multiplied by 13 plus the last one 125 multiplied by 10. Let me do the calculation. So this is 2200 plus 650 plus 3150 plus 1250 plus 3575 plus 1250. So the IBFS for this particular transportation problem using Vogel's approximation method is 12075, right? So this is how you implement the Vogel's approximation method to find out the IBFS for any given transportation problem.